All right, today we're going to start talking about rational expressions. And the first thing we're going to learn to do with rational expressions is to learn how to add and subtract rational expressions. So the lecture for today is to add and subtract rational expressions. All right, so the first thing that you would want to do in this case is you want to define a rational expression. Everybody should know what a rational expression is, but if you don't know, I'm going to write a little note here for you. So what is a rational expression? And let me put an answer here for the rational expression. So a rational expression is a fraction in which both the numerator and the denominator are polynomials. It has the form, and let me just put that form that it has. So it has the form p of x divided by q of x. Now, p and q are both polynomials. So let me just put that label here. So this and this are both polynomials. All right? And there's a stipulated condition for one of the polynomials, which is this one. And that condition is that it cannot, when you evaluate this polynomial at a given x value, it cannot be equal to 0. If it is that it's equal to 0, then it's undefined, and we have a problem if it's undefined. Now, to solve problems involving rational expressions, you would need something equivalent to an LCM that you have in fractions. So like the LCM of the denominators is what we would need. We'll call it the lowest common denominator. All right. And this is what we would need to solve problems, as I said. So to solve problems involving rational expressions, we need the least common denominator for the denominators in the problem. All right. Now, as I said, let me just highlight that least common denominator. This here is very similar to your LCM that you would use in fractions. All right. Similar to LCM, so your lowest common multiple. This one is the least common denominator. So let's do a formal definition for this, and I'll say, I'll put it in green. So I'll say something like let me just put it there. So for denominators, d1x and d2x, the lowest common denominator L of x leaves no remainder when L of x is divided by d1 of x and L of x is divided by d2 of x. All right, so it leaves no remainder. So let me give you some steps, some general steps that we can use to solve problems involving the addition and subtraction of polynomials, and then we'll solve a few examples. So let me just put this in yellow with some text over here. And we're going to say steps for adding and subtracting rational expressions. All right. The first thing that we want to do is we want to factorize the denominators. So factorize the denominators. right? The next thing you want to do is you want to determine the lowest common denominator. Then the next thing you do is to adjust each rational expression so their denominators is equal to the lowest common denominator. And then the fourth one is to add or subtract the numerators. And then finally, 5, we want to simplify the results by factorizing. All right. These steps are very simple, straightforward to do. They sound cumbersome, they sound long, and it looks like a lot to do, but it's not. Let's start off with first, let's do some examples and you'll see what I'm saying. All right, so we'll start off with the first example, example 1. And example 1 is 3 over x plus 2 over x. Now we can notice that we have the same denominators. So in this case, I don't need to worry about anything. I can just simply put that lowest common denominator here and then simply put back 3 plus 2. And then the answer would be, what is that, 5? So 5 over x. All right? So the expression is already simplified. All right? So the expression is already simplified. So we don't need to do anything like factorize the top and the bottom and simplify. Now you see the point of doing the factorizations that we did before. Let me show you some more of it so that you can get more experience with looking at it and solving it. Let's see, ex2. So we want to simplify 5 over x minus 2 over x plus 1. And we can check that the denominators are x and x plus 1. I'm really sorry about the grinding in the background, but I can't control the neighbor. They will probably be doing that for most of the day. Anyway, so these are the denominators. LCD would be x into x plus 1. And now we can just simply make everything look like that. So to make everything look like that, I'm going to need to multiply this by x plus 1. All right, so if I multiply this by x plus 1, I'll be able to get this LCD here. And to turn this into that LCD, I would need to multiply by x. Now, just because I am multiplying the denominator, I'm going to have to multiply the numerator as well. And this is, in essence, multiplying the number by 1. Right? This is in essence multiplying the number by 1. If I take 5 over x and I multiply it by 1, then I will get 5 over x. In this case, I'm choosing a different way of writing 1. I'm choosing to write 1 in this case as x plus 1 divided by x plus 1. All right? This here gives me 5 into x plus 1 and x into x plus 1. So it's the same number as 5 over x, but it's just in a different form. All right, so I'm going to use this now to expand. So I note that once I change each of the denominators, I'll get x plus 1 on the bottom. Actually, not x plus 1, x into x plus 1. And then at the numerator, notice that I would have to take this and multiply by this. So I have 5 into x plus 1 at the numerator, and then I have 2 into x. So I'll put back the minus sign, 2 into x. And now I simply expand the top. So expanding the top, I will get 5x plus 5, and that is using the distributive law again. And then negative 2 by x will give me negative 2x divided by x into x plus 1. And I'm going to simplify the top. So 5x minus 2x is going to give me 3x, and then plus 5, and then divided by x into x plus 1. Now there's nothing I can factorize the top with, nor the bottom, so this is the simplest form, and that's the answer. Let's do another one. I won't explain as much detail as I did on this one. Let's say, for instance, we have something like x over x squared minus 1 plus 1 over x minus 1. Now, again, what we have to do is we have to factorize all denominators, and I can see that this is the difference of two squares. So my denominators, so factorize denominators, and I will have that x squared minus 1 is equivalent to x plus 1 into x minus 1. And this, again, is our difference of squares. And now I will have to find the denominators. So the denominators are x minus 1 into x plus 1 and x minus 1. Now I can see that a common factor in the denominators is the x minus 1. And I can see that the remaining factors here is x plus 1. Right? So I put down all the common factors first, and then I put down the remaining factors. Now you can see that this here is the denominator. So I'll just simply rewrite all of these. And I can see that if I rewrite the first one, I'm going to get x over x plus 1 into x minus 1 plus 1 over, and I can see right away that I'm going to need to multiply this into x plus 1 at the top and the bottom so that I would be able to get the exact same denominator. So I will have that, and then I will have x minus 1 into x plus 1. All right, now I have the denominators. Oopsie, I have to put the x plus 1 at the top here. Right, now I have the same denominators, and I can rewrite the entire thing to work it out. So I will have here x plus 1 into x minus 1, and then I can put x on top here since I didn't have to multiply this one by anything. And I would have to put plus, open bracket, 1 into x plus 1 over on this side. I can expand now with the distributive law. So this is 1 into this and 1 into that. So we have x plus 1 all over x plus 1 into x minus 1. I can see right away that I am going to get 2x plus 1 all over x plus 1 into x minus 1. I don't see anything that I can factor out or cancel to simplify this any further, so this here is the final answer. Let's do the fourth one. Okay, so for this one, let's do something where you can actually get some kind of simplification happening. Should I? Let's not do that. Let's just continue so you can get some more practice on this. So x squared minus 4 minus 1 over x plus 2. Again, we want to factorize. We want to factorize the x squared minus 4, and we're going to get x plus 2 into x minus 2. Again, difference of squares. The denominators are going to be x plus 2 into x minus 2 and x plus 2. Again, we can notice that we have x plus 2 in common and then x minus 2 as the extra, so we can rewrite everything. Let's first rewrite this one. So this here is going to be x plus 2 into x minus 2, and then minus 1 over x plus 2, and we're going to have to multiply this x plus 2 by x minus 2. Again, same thing on the top here, multiply by x minus 2, and then we say that common denominator is x plus 2 over, sorry, x plus 2 into x minus 2. This here would be 2 minus 1, open bracket, x minus 2. Simplify, again, we can have, sorry, expand with distributive law first. We get minus x plus 2 divided by x plus 2, x minus 2. Then we can add this, we get 4, so this here would be 4 minus x over x minus 2, x plus 2. All right, that's the answer there. Let's do another one really quickly. Last example, and let's make it really cumbersome. All right, let's make it really cumbersome. Something big. Let's use a quadratic, big quadratic. So let's say this is example 5, and let's say we have x squared minus 3x plus 2 and then plus 1 over x squared minus 1, and we're looking to factorize. So we're going to factorize x squared minus 1, which is equivalent to x plus 1 and then x minus 1. And then we're going to factorize x squared minus 3x plus 2, and we're going to get something very simple. So we have x, and we have 1 by 2, so negative 1 by negative 2 is going to give me a positive 2, and it's also going to add up to give me negative 3. And then we can simplify and rewrite, so we're going to rewrite this. So this is x over, you know what, I did not look at the denominators yet. So the LCD, lowest common denominator, I can see that I have x minus 1 as one of the factors already, so I'm going to put that x minus 1. I can see I have x plus 1 remaining, and I can have x minus 2 remaining. All right, so let me rewrite the bottom. So I'm going to rewrite the first one with the factors. So I'm going to have x minus 1, x minus 2, adding to 1 over, rewrite this, this is x plus 1 into x minus 1. Now I have to make the denominators. I'm seeing that I have this factor in here, I have this factor in here, I'm missing this factor, so I'm going to have to multiply by x plus 1 and x plus 1 here. And let me check this one. So this one here is plus minus, and then the 2 here is missing. So x minus 2, so x minus 2. All right. Now I write as the common denominator. So my common denominator is x plus 1, x minus 1, x minus 2. Like that. Then I have x into x plus 1 plus 1 into x minus 2. I expand with the distributive law now. So I have x squared plus x minus x, plus x, sorry, plus x minus 2. And then divide this by x plus 1, x minus 1, x minus 2. This here would be equivalent to x squared plus 2x minus 2 divided by x plus 1, x minus 1, and x minus 2. I can try and see if I can factorize this, but I don't see any factors that I can have here. 1 by 2 is 2, and if I add them up, I'll get 3, and if I subtract them, I'll get 1. So this here definitely can't work out. However, if the situation allowed me to factorize here and allow me to have something on the underneath here cancel with one of the factors on top here, I must do that. But since this cannot be factorized, since this cannot factorize, then that means that that's final. This is the final answer. Right? This here is the final answer. So it looks complicated, but it's the final answer because I can't factorize anything and make it simpler. All right, let's say, for instance, that I had here something like x squared plus x minus 2, and that would give me factors of x minus 1, minus 1 plus 2, right? So notice that I have these factors here. If I had something like this, if I could have factorized to something like this, then I can simply cancel this here with this underneath here, and that will reduce the factors a little bit. All right? So you have to look and see if you can factorize it as much as possible so that you can cancel whatever needs to be canceled. Let me give you some problems, and that will be it for this lesson. So problems. Let's say 4 over x plus 3 over x. Then the next one is 2 over x minus 3 minus 1 over x plus 3. Then the third one would be x over x squared minus 9 plus 2 over x plus 3. Fourth one, 3 over x squared minus 4x plus 4. Then minus 2 over x minus 2. And then the fifth one will be 2x over x squared minus 5x plus 6, adding to 1 over x squared minus x minus 6. All right, try and solve those problems and see if you can get some answers. And if you want, I can work these out for you to verify them, or you can just simply use an online calculator to solve these problems. All right, so that'll be it for this lesson, and I will see you tomorrow when we start talking about the multiplication and division of rational expressions.